32. Looks like we're doing pretty good on time. We have about 17 minutes to work our last two problems here. Take a breath for a second. Focus. A car is driving at constant velocity of 70 feet per second when it passes a police car sitting on the side of the road. The police car starts chasing a car the instant the car passes it, accelerating at a constant rate of 14 feet per second squared. How much time does it take for the police car to catch up with a speeding car? A little bit different than problems we've seen in the past, so let's think about it. We've got two things moving. Okay, when they pass each other, that's sort of when we start the problem, and then when they catch up, that's when the problem goes to the end, and we want to how much time, so we're looking for some sort of time here. The other thing that's the same is since they're starting, our problem is going to start when they're at the same location, and it's going to end when they're at the same location. That says the change in distance is going to be the same. The difference is, of course, one starting from rest and accelerating, the other's driving at a constant velocity. So this is actually similar to the elevator problem we worked in lecture. Okay, and where we want to set what we know together. So we're going to say, just to show the grader, we know what we're doing. Delta S of the car is going to be equal to delta S of the police car. So we'll label that like that. Alright, so we know a bunch of initial information about each one. So we'll use the general form of the equation, S2 equals S1 plus V1 delta T plus 1/2 AT or delta T squared. Okay, we'll use that for each one of these, and so we're setting the delta S equal to each other. So what that really says is that the delta S of the car is going to be the velocity of the car, and I'll just use C, times delta T, I'll just use T, plus 1/2 the acceleration of the car, T squared, and a similar thing for the police car. The velocity of the police car times time, plus 1/2 acceleration of the police car times time squared. Okay, that was, as I said, a little bit different, so we had to think about how to set it up, and it actually is going to work out pretty easily now. I could notice that T equals 0 is one of my solutions, and that sort of makes sense. They're at the same position at when we start the problem. Okay, so I'm going to cancel out that T, which can divide everything by T basically, which cancels out the squareds and gets rid of the T terms. Alright, we'll go ahead and plug some numbers in. The velocity of the car, 70 feet per second. The acceleration of the car, constant velocity. Okay. The velocity of the police car when the problem starts, sitting, another 0. Acceleration of the police car, 14. And that's T. Wow, that worked out pretty nice. T is equal to, bring our calculator back. Oh, looks like I can do the algebra pretty easily here, so let's get out of that. 70 times 2 divided by 14. T is 10 seconds. Alright, so we're at 37 minutes into the test, and we're basically, except for the one we have to go back to, done. So I'm going to make sure this one is right so I don't have to come back and check it. So I'll go ahead and plug this in. The delta S of the car After 10 seconds would be 70. It would be 70 times 10 because it's going at constant velocity. And the delta S of the police car is going to be 1/2 times 14 times 10 squared. So that's a check. Again, that comes from this term right here, where the velocity of the police car initially was 0. Okay, so if that equals 700, I'm pretty sure that my answer's right. So this is my check here. So let's see, calculator. Oh, damn it. I did not mean to move that. Let's bring it back. I don't know how I moved it really. Alright, excuse the short interruption there. Got a little discombobulated. But that happens on a test too. I was trying to get the calculator to run this number to double check. And so I'm going to do 0.5 times 14 times 10 squared. Come on, 700. There we go. Oops, better put my answer in. I'm looking for the time. So that's 10 seconds. Again, it's really good, or not again, but just to make a point, for practicing for the exam, it's really good to work through it just like this. Put away everything, try to get away from distractions, work it just like it's a real test.